Hello, so this is your answers to the worksheet. By the time you've watched this video, you should have already done these answers. I appreciate you will probably be writing these on paper if you don't have access to a printer, but that's absolutely fine. So I'm just going to go through now and answer as we go. Let me see if I can just move that up there. So, two students investigate the resistance of a wire. They take a length of wire to a meter ruler and connect it to a resistance meter using crocodile clips. There you go, nice little diagram there. Look at their results. Here we go, so we've got attempt 1, attempt 2, attempt 3. Oh gosh, you can see that the table columns are all off, aren't they? Right, so this is clearly the length of wire. This is the resistance attempt 1, resistance attempt 2, resistance attempt 3, and the mean. So 1, 2, 3. Yeah, hopefully you were able to figure that one out. Then describe the pattern shown by these results. Use data in your answer. Now there are 2 marks available for this question. To get 1 mark, you could say the longer the wire, the bigger the resistance. That will get you 1 mark. To get 2 marks, however, you need to use a phrase, which is that they are directly proportional. Now, you may have come across this phrase in maths. What it means is if you double one, you are going to double the other. That's the easiest way of explaining it. So if we have a look, for example, at the length of wire. If I double the length of wire from 25 centimetres to 50 centimetres, let's now compare that to the mean resistance. The resistance goes up from 8.5 to 16.4. That is effectively double. So I've doubled the length by going from 25 to 50, and the resistance has also doubled. That's what directly proportional means. Now, if in doubt, that is a really, really good phrase to use. It kind of gives you more detail than just saying one gets bigger, the other gets bigger. As I say, saying increased length, increased resistance got you 1 mark. Using the phrase directly proportional got you 2 marks there. Okay, let's go on to II. The students made 2 mistakes when they recorded their results and completed the table. Identify the mistakes and explain what they should have done. So there are 2 mistakes we need to spot and we need to explain them. So let's do mistake number 1. Where are we? Oh, easy, right. I'm going to change colour for this one. Check out this mean. Look how many decimal places there are. Far too many. You should always record all your data to the same number of decimal places. So everything else there is 1 decimal place. That is 3 decimal places. That is a mistake. So 8.533, which is 3 decimal places, should be 8.5. 1 decimal place. Okay, so that's quite an easy one. Now let's look for another one. Oh yeah, okay, right. Look at the length, 50 centimetres, and the 3 results that come after it. So 50 centimetres, first result, 16.2, then 16.1, then 16.4. But their mean is 16.4. That is clearly a miscalculation. The average, as we know, should be 16.2 plus 16.1 plus 16.4 divided by 3, which should come out as 16.2. So 16.4 is wrong, should be 16.2. So they've made an error in their calculation. These, by the way, are really common types of questions. You'll notice they're not actually asking you any physics, they're just asking you practical type questions. And you could get asked these questions in biology or chemistry. It's not knowledge-based, it's more spot what's happened. So, I. The students have correctly handled an anomaly in their results. Remember, anomaly means something that doesn't fit in the pattern. So something that looks a little bit out of place. But luckily they have correctly handled it. Identify the anomaly and explain how it was correctly handled. So let's have a look at the results again. One that doesn't fit. Oh, here we go. Okay, can you see? Length 75 centimetres, three results, 23.5, 23.8, and then 18.7. Clearly, 18.7 is our anomaly, doesn't fit. But how did they correctly handle it? Check out, I'm just going to rub out, sorry, I do things. Look at the mean. Oop. How do I go back to this? Oh, that's what I was looking for. Sorry for all my noises that make. Right, check out the mean. Can you see the mean for this is 23.7. It is clear they have not taken into account the anomaly. So the anomaly was 18.7, but not counted in the mean. And that is what you should do. If you have an anomaly in your results, do not use it when you're calculating an average. You just completely ignore it. You just take an average from the other two, basically. All right, so the actual mean resistance values are more than expected. Suggest two possible errors with the experiment. So things that could possibly go wrong. Let's have a little look at the setup just so we can see. So resistance is more. What could cause more resistance? First thing, it might not just be the resistance from the wire that we're actually measuring. You would have resistance from the crocodile clips. You would have resistance from the leads. All of those might add on. So that could be, if I just said that, I've got two examples right there. Also, check out where they've actually put the crocodile clip. That is not the end of the wire, is it? Can you see there's a little bit of a gap? Darn it. Can you see there's a bit of a gap there between the crocodile clip and the end of the ruler? So actually, they'll be measuring a bit longer wires than they were expecting anyway. So they should make sure the crocodile clip is actually at the end of the ruler. So I think instantly I've got three things. What else could there be? Oh, I know. Do you remember when we did this experiment and I told you not to leave things on, not to leave the power pack on because things would get hot and they'd smell like burning? Well, if they didn't turn their power pack on and the wire did get hot and it did smell like burning, we know from earlier in this lesson that when things get hot, their resistance increases. So if this was hot, the resistance would be higher. So I think I'm only being asked for two, but there are four possible things I could write down. The resistance of the crocodile clip, the resistance of the lead, they all get added on, the fact the crocodile clip isn't on the end, and the fact that it could get hot. So there are four possible things you could write down. You only need two of them. So where are we? So resistance of lead and croc clip added on. That's meant to say added. It's quite hard to write with an Apple Pencil, believe it or not. Croc clip not on the end, extra wire. And it might have got hot. Right, for one of the errors, suggest how the experimental procedure could be improved. So we'll pick one, shall we? Let's go with the get hot. How could we stop it from getting hot? Turn off the power pack. How could we correct the fact the crocodile clip is not on the end? Put it on the end of the wire, the end of the ruler. That seems fairly obvious. Resistance of the lead and crocodile clip added on. Not much you can do about the crocodile clips, but if you had shorter leads, that would mean that you'd have less resistance overall. So pick one and you just give me the alternative. And that's it. Hopefully that made sense. Please let me know if you have any questions. I'll see you soon.